This video is to walk you through the regression problem in the final exam. So the prompt reads that you are a cost analyst for Demeter Solutions, and this company is having issues in estimating their overhead costs. They seem to fluctuate from month to month, and not having a good idea of what your cost may be can create a lot of issues for the company with respect to pricing, planning, and a host of other related issues. So, as the cost analyst, you believe that machine and maintenance hours are the primary drivers of what creates overhead costs. You know, the cost of inspecting the machines, the production machines, to make sure that they're working, and of course they're going to break down at times, and fixing those issues cost a significant amount of money. So you request the data for monthly data on machine and maintenance hours. So here is the regression information. Let me go ahead and go to here. So here you can see we have 15 months of data, and here are the overhead costs along with the machine hours and the maintenance hours. Okay, so these were the total overhead costs whenever we had 248 machine hours in this month and 23 maintenance hours. So the regression, essentially what it does is it just looks for relationships between variables. And we're going to call this, this is going to be the Y variable, or the outcome variable. This is what we are trying to predict, okay? And these are going to be the X variables, or what I like to call the predictor variables, okay? So these are, two items, machine and maintenance hours, are going to try to predict the overhead costs, the outcome, all right? So to do this, we're going to go into data. Oh, keep in mind that I use a Mac, so my interface here, or my layout, may look quite a bit different from yours, but you'll still have all the same tools in the Microsoft version there, okay? So with, before you can run the regression, you'll have to make sure that the analysis tool pack is added in. It's an add-in that you for Excel, and it's free. You don't have to purchase anything. And if you have trouble finding or adding in the analysis tool pack, just let me know. It's really, once you figure out how to do it, or where to find it rather, it's a pretty simple process. Okay, so I would think a lot of you probably already have it. I think it's kind of standard for the university version that we all have, but you want to make sure that you have that first. So to run the regression, you go to data analysis, okay? And then you'll see, you may have to scroll down a little bit, and you should see regression. And hit OK, of course. And let me exit out some of this information that I already had. I ran it just to make sure everything was working properly. All right, so the first thing that you want to do is select your Y range, okay? So the Y range, again, is going to be this Y variable, the thing that we're trying to predict, overhead costs. So you want to go ahead and select that, and make sure you get the label as well, okay? And then for the X range, you hit that, okay? And then you can just get both of them at the same time. All right. So you want to make sure that you do select labels, since we did include the labels in there. It just makes the analysis a little bit cleaner, easier to read, and make sure that you don't start confusing variables and everything. You want to make sure that this is not selected, and we really don't need to worry about confidence level. It's already at the confidence level that we need. You can select these things if you wish. They probably won't mean a whole lot to you. I just kind of like to select them to just to satisfy my inner nerd there and look at some of this stuff. So then, of course, you just hit OK. I've already ran the regression, so I'm going to just cancel it out here because I already have the data. So, but once you hit OK, actually, maybe I'll just do it again just to make sure everything, I did it all right there. Yep, it looks good to me. All right, so here's the output. That's what you should see here. So here's what we need to look at when we run a regression. The first thing that we look at is the multiple R, and we call this thing the correlation coefficient. And this tells us what type of relationship the variables have, along with the strength of the relationship. Okay, so there's really three groups of relationships. A positive relationship is when as one variable goes up, the other variable or other variables go up as well. In this case, like it'd be like exercise and being healthy. The more you exercise, the healthier you get. That would be a positive relationship. Or the more employees you have, the more employee expense that you have. That would be a positive relationship. A negative relationship is where one variable goes up. As one variable goes up, the other goes down, or vice versa. And then, of course, there's no relationship. So, as we see here, usually we would define a perfectly positive relationship as 1. A perfectly negative relationship would be a -1. And the closer you get to 0, the analysis suggests that there's no relationship between the variables at all. So here we see that it is positive and that it's a 0.96. So that is a very strong positive relationship, meaning as maintenance and machine hours go up, we should expect overhead costs to go up as well. Okay. All right. So the other thing that we want to look at is the adjusted R-squared. Since this is a multiple regression, meaning that we have 2 predictor variables, machine and maintenance hours, we would look at the adjusted R-squared rather than the R-squared. So here, this tells us how much of the outcome variable, overhead costs, can be predicted by the predictor variables. So this tells us basically 0.915 that 92% of the changes, the month-to-month changes in overhead cost, can be predicted by just these 2 variables, machine and maintenance hours. So there's 7.5 other percentage points out there somewhere, or some other kind of variable or variables that account for that other 7.5%. But this is or 8% if we want to round it up there. But it's that explains an awful lot. So we did a pretty good job at identifying what are the cost drivers that drive overhead costs. So strong positive relationship, and when we look at the adjusted R, we do see that these 2 variables do account for a lot. The adjusted R-squared and the R-squared will also be, sometimes they're called the coefficient of determination. All right, so one more thing that we need to do to just check, the analysis to make sure everything is, that we can use this cost estimate formula, is the p-values, okay? So when we look at the p-values for machine and maintenance hours, we notice that they're both under 0.05, and that's what we want. Basically, the p-value is just a check to make sure that there was not some kind of statistical anomaly that would account for this other for the results that we got. Without going into a whole lot of statistics and math, let's just say that if p-value is less than 0.05, then we can use these. We can be confident that these are the numbers that we are getting are accurate and representative, and it's not some kind of weird anomaly going on. All right, so in running this regression, we can do two things. Again, is to figure out what are the drivers of those overhead costs. And again, we accounted for about 92% of that. And then the second thing is we can derive a cost estimate formula from this analysis. And here's how we do that. The first thing that we look at is the intercept and that coefficient. So we're going to create this cost estimate formula, okay? And this 5018 is basically the total fixed cost from month to month. If you remember from accounting 202, fixed cost don't change much or at all from month to month or over short periods and longer periods. In the long run, eventually they can change, but in short run, fixed costs don't change. That's why we call them fixed. Those costs don't depend on anything. They're just there regardless if we do anything or not. If we make 0 items, we still have to pay the lease on the building or the factory, so that we would still have those costs, for example. Okay, so the second thing we want to get is the coefficients for machine and the maintenance hours. So machine hours is 8.17 rounded, and maintenance is 123.12 rounded, or 13 rounded rather. If I'm going to be consistent, let me just change that real quick. It really doesn't matter. You can round them up to whole numbers even if you wanted to, but accuracy is always good, especially when it comes to costs. All right, so basically, this is our cost estimate formula. All right, so we have total fixed cost, and these are the variable costs per hour. So for an hour of maintenance cost, or machine cost rather, for every hour that we have in a machine hour, we should expect a variable cost of $8.17. For every hour that we have in maintenance cost, we have $123.13. So now we can estimate our costs. Okay, we've already determined that we can use this formula because we looked at the correlation coefficient and the coefficient of determination. We've determined that it's a strong positive relationship. So there is a relationship, and as one goes up, the other variables go up, as the predictor variables go up, the outcome variable goes up, which is what we would expect. So that's logical and sound, so we're good there. And we've looked at and we've pretty well got almost all of the predictor variables, almost 92%, which is really good. And we've also looked at the p-values and looked at and determined that we don't have to worry about any kind of weird statistical anomalies accounting for our formula. So now that we have that formula and that cost estimate, we've got the information that we need. What we can do now is that we can go back and predict costs. So here, excuse me, let me get that back here. All right, so now what we can do is predict cost, as I said, overhead costs So if we have, if we want to know our cost at 300 machine hours and 20 maintenance hours, all we have to do is just substitute that 300 into the X1 and the 20 into the X2. And that will give us our outcome or our prediction of overhead costs. Okay? And we would do the same for the next one. 400, we would substitute in X1, and then 25 in X2, and then we would just solve and we would get an estimate at for our overhead cost at these levels, this level of machine hours and maintenance hours. Okay? So I hope that helps. Of course, if you have any questions or something wasn't, really clear or anything, just feel free to email me. All right. Thank you very much.